Hi, welcome back. This is Rakesh Naik. In our previous two videos, we have discussed 10 problems on how to design DFAs. In this video, we are going to take another 5 problems which will be a little bit more complicated than the previous problem. But before we start, a small information I'd like to share. In this channel, we produce every video in 2 different languages, Hindi as well as in English. If you want to watch this video in Hindi, kindly follow the link given in the description. And if you have not yet subscribed, please subscribe and press the bell icon so that you will get regular updates from this channel. So, let us start. Let us discuss this problem. We need to design a DFA over the input symbol 0 and 1. And that will contain the language 0 to the power n and then 1. It means a series of zeros end with a 1, where n is greater than equal to 0. So in order to design the DFA, let us find the strings which belongs to this particular language. So when n equal to 0, we'll be having 0 number of zeros, so only 1. If n equal to 1, we are having 0 and 1. When n equal to 2, 0, 0, 1. When n equal to 3, 0, 0, 0, then 1, and like that. So the minimum string length that is accepted by this particular language is of length 1. It means what? I need one transition, and for one transition, a minimum of 2 states are required. So Q0 is the starting state. With transition 1, it goes to the final state, that is Q2. As we know, in DFA for all states, all input symbols must be discussed. On Q0, 1 is discussed. What about 0? It means before that as many 0 comes also, it is satisfying this particular language. So nothing to worry if zeros are coming before this one. So on Q0, input symbol 0 and 1 are discussed. Now on Q2, we have to discuss the input symbol zeros and 1s. If we are on Q2 and by giving input symbol 0 and 1, we are supposed to go to another state which is Q1 and which is a dead state. It means after this state, by no means we can come to the final state. So this is the required DFA which satisfy the language 0 to the power n ending with 1, and here n is greater than or equal to 0. Let us discuss one more problem. Here we are designing the DFA over 0 and 1, and it will satisfy the language 0 to the power m, 1 to the power n, where m and n supposed to be greater than or equal to 0. It means we are having a series of zeros then series of 1s. So how the string will look like? Let us see. So the string will be something like this. If m equal to 0 and n equal to 0, the string will contain epsilon. If m equal to 1 and n equal to 1, we will be having 0 and 1. If m equal to 2 and n equal to 1, 0, 0, 1. It means m and n are not same. They can be different. So these are the strings that need to be accepted by our DFA. So the minimum string length is 0. It means it is accepted by epsilon. So when we entered into the initial state, that becomes the final state. So m equal to 0 and n equal to 0, it means with epsilon this becomes the final state. So if at least 1 we are taking, so any number of input after that will supposed to be again in final state. So with transition 1, again it is coming to a state Q1, again it is a final state. Now we have to discuss the input symbol 0 on Q0. So before Q0, we can have any number of zeros because m is greater than equal to 0. So before the first one, any number of zeros can be there. Now we have to discuss about the input symbol 0 and 1 on Q1. So whenever we will give any number of 1 after this one, obviously it will accept because n is also greater than or equal to 0. Here if you are getting the first symbol, m is 0 and n is 0. If at least m equal to 1, again it will come here, again it is a final state. If n equal to 1, we have to have at least one transition here and we'll get at least 1 and it will come to the final state, and more than 1 will get here. Now what about the 0 transition on Q1? So on 0 transition, after a single 1 comes also, it should not contain any more 0 after that. So after this transition 1, if at all any 0 comes, it's supposed to go to a dead state. I hope you understood this. And again on Q2, after that whatever zeros or ones comes, it's supposed to be in the same state Q2 as it is a dead state. Let us discuss one more problem. Here we are going to design the DFA over 0 and 1 with language 0 to the power m, 1 to the power n. Here m and n are strictly greater than 0. In our previous problem, it was greater than or equal to 0. In this problem, strictly greater than 0. So let us see what are the strings that satisfy this particular language. We'll be having at least m equal to 1 and n equal to 1. With m equal to 1 and n equal to 1, the string is 0, 1. If m equal to 1 and n equal to 2, we are having 0, 1, 1. If m equal to 2, n equal to 1, we'll be having 0, 0, 1. Like this. So at least 1, 0 and 1, 1 supposed to be there. So the minimum string length that this language contains is 2. It means we need 2 transitions. And for 2 transition, we are having 3 states. So from the initial state we are taking 0. We came to Q1. Again we are taking the transition 1. We came to Q2. And Q2 is the final state. Now let us discuss what are the other input symbols that are missing here. On Q0, 0 is defined. What about 1? Before that any number of 1 comes, is supposed to go to a dead state because it is starting with 0. So whenever a 1 appear before anything else, then it's supposed to go to a dead state. For state Q0, 0 and 1 are defined. On state Q1, 1 is defined. What about 0? If any number of 0 comes, then it is welcome because before this one, any number of 0 we can have. As we have already told that m is greater than 0. So on Q0 we can have any number of zeros. Now on Q1, 0 and 1 we have defined. Let us see about Q2. On Q2 we have to define 0 and 1 input symbols. If at all any number of 1 appear, that is also welcome, no issue because n is supposed to be greater than 0. So after first 1, any number of 1, we don't have any problem. So we can put a self loop here. If any more 0 appears after this last 1, it should not go to the final state. So it should go to the dead state. So on Q2 also we have defined 0 and 1. What about Q3? Q3 is also a state. Here also we need to define 0 and 1. After coming to Q3, that is the dead state, as many 0 or as many 1 you give, it's supposed to be in the same state. Let us discuss one more problem. Here we are taking 3 variables, A, B and C, and we are taking A to the power m, B to the power n, C to the power p, where m, n and p supposed to be greater than or equal to 0. So let us see what are the strings this language is having. If m, n and p are 0, we are having epsilon. If m equal to 0, n equal to 0 and p equal to 1, we are having only c. If m equal to 2, n equal to 0 and p equal to 0, we are having 2 a's. So like that, we are having all these combination of strings that are possible. Along with that, we are having epsilon also. So let us try to design the DFA. We have already seen this DFA will accept epsilon. It means the initial state is supposed to be the final state. So we can have Q0 and on that any number of a's we can give greater than or equal to 0. So we can have 0 number of a's or more number of a's. If we are thinking about B, another state we need, that is Q1, it's supposed to be again be a final state, and any number of B's on that also we should not be having any problem. And on C also any number of C, it should not be having any problem. But from A to B, the transition is supposed to be on Q0, by giving B, it's supposed to go to B because it is ensuring that at least one B is there. If we got at least one B and after that any number of B's we can get from this loop. Let us assume right now that we are in state Q1. At least one C will take me to the state Q2. And after that any number of C's, there is no problem on this. Now on Q0, input symbol A and input symbol B are discussed. What about input symbol C? On input symbol C, it can also go to Q2 because we have already seen A's may be there, may not be there, B may be there, may not be there, and C may be there, C may not be there. So directly C also can come. It means only C also will be accepted. So after coming to Q0, on C transition, it can go to Q2 and get accepted. Now on Q0, A, B, C we have already defined. On Q1, B and C already being defined. What about A? When we are in Q1, at least one B we have received. So after B, there is no A. It means if we get A over here, it's supposed to go to a dead state. Now on Q1, A, B and C we have already defined. On Q2, we have defined input symbol C. It means at least one C we have received. So after C, we should not be having any A's or B's. So on any number of A and B, it's supposed to come to a dead state. And after reaching the dead state, any number of A, B, C, it's supposed to be in the same state, that is in the dead state. I hope you understood this problem also. Let us discuss one more problem. A small change is there. We are taking A to the power M, B to the power N and C to the power P with M, N and P greater than or equal to 1. It means at least one M, N and P supposed to be there. So the string of this particular language will be ABC, AABC, ABBC, AABCC or something like that. It means at least M supposed to be 1, N supposed to be 1 and P supposed to be 1. We can observe that for this particular language, the minimum string length is 3. So for minimum string length 3, we'll be having, we started with Q0, on A we came to Q1, on B we came to Q2 and on C we came to Q3 which is the final state. Let us try to discuss about other input symbol. On Q0, A is defined. A is supposed to be at least 1. So on first appearance, it gone to Q1. So before that, B or C supposed to be rejected and it is coming to a dead state, that is Q4. Now let us discuss about Q1. As you are in Q1, you have accepted 1A and on B you are going to Q2. So A and C are missing. Any number of A you can give before this B, so we can put a self loop here. And on C, it's supposed to come to a dead state. Because after A, you cannot have C. You can always have B. On Q0, we have discussed A, B and C. Let us try to discuss on state Q2 what are the input symbol missing. We are having input symbol A is missing and B is missing. We have already received A and B. It means any number of B before this C will be okay. So because before this C, any number of B may appear. So we'll put a self loop here for B, and after B, we cannot have any number of A's. If A appears, it's supposed to come to a dead state. Input symbol A, B and C are discussed. From Q0, we have given A reached Q1, we have given B reached Q2, and on Q2 we have given C and reached Q3. On Q3, let us discuss the input symbol A, B and C. After receiving the first C, any number of C is okay for me. It is not hampering my DFA. But after a single C, I cannot have A's or B's anymore. For A and B, it's supposed to come to a dead state. And on Q4, any number of A, B, C you give, it's supposed to be in the same dead state. I hope you understood these 5 problems also. If you are having any problem, do comment. I'll definitely reply. And if you like the video, give a thumbs up and share among your friends. In our next video, we are going to take another 5 problems which will be a little bit more complicated than these problems. So see you then. Take care. Bye.